Hi, this is Miss Townsend, and in this video I'm going to introduce you to the fundamentals of trigonometry. So before we get going, this video is designed so that there's time for you to practice math and press pause. So to get the best out of this video, it'd be great if you had with you pencil or pen, some paper, and your scientific calculator. That's really an important part of trigonometry. And in fact, we need to talk a little bit about your calculator. Calculators have different modes. They do different things. There's lots of buttons you've never used. Well, we're about to use some buttons, which are the trig buttons, which sort of are always in a row: sine, cosine, tan, or sin, cos, tan. But those aren't the real words. They're just shortcuts. Sine, cosine, tangent. So in order to test that your calculator is in the correct mode, this is what I want you to type in. Sine 30 equals. And if you type that in and you get 0.5 on the display, then your calculator is set up the way we want and we can get forward and start doing the math. However, if you don't get 0.5, this is a video I can't really problem solve with you. So my suggestion is do look at your calculator name and model. What you're looking for in terms of how do I change this? How do I make it right? Is you want to do a search with the word degree mode. Because the issue is that there's different ways of measuring angles. You're probably only used to like 90 degrees and 30 degrees and degrees. And we want our calculator to measure in degrees. So hopefully you can find that information, or your calculator is already set up right. So trigonometry is about triangles fundamentally. So let's review what we know about triangles. Well, we know that triangles have 3 sides and 3 angles. That's the definition of a triangle. There's some pictured. And there's this fact here that we will occasionally use, which is that the sum of the angles in a triangle is 180 degrees. So if you take all of the angles in the triangle, you added them together, you should get 180. And that's kind of most useful in situations where, for example, if I know these 2 angles, then I can use that information to find the missing angle. So the 2 angles I know add to 140 degrees, 130 plus 110. So what I'm missing is 40 degrees. So I can use that information to tell me what a missing angle is if I know 2 angles. That's good to know. It will come up. Now, there's also my favorite type of triangle. This is really where trig lives, which is with right-angled triangles. So a right-angled triangle is one of the triangles where you have a 90-degree angle marked. So I'm just reminding you that we mark a 90-degree angle with that little box. And so what's so great about right-angled triangles? Well, in addition to the fact we already talked about, all angles add to 180, we already know an angle in the triangle. Just by saying it's a right-angled triangle, you know there's a 90-degree angle. The other thing that's important that makes right-angled triangles very special is that there is a relationship between the side lengths called the Pythagorean theorem. So you should know from previous grades that if I know 2 of the sides on a triangle, so let's say I knew this side was 12 and this side was 14, then I could calculate the missing side using the Pythagorean theorem. And just a reminder, using the Pythagorean theorem, it's really important that you put the hypotenuse, the side opposite the 90 degree, in the longest side, in this position over here where it's alone. And then, so in this case, I would have to write 14 squared equals 12 squared plus b squared. It doesn't matter which one's a or b. And then I would have to do some subtraction and square rooting. But that's really important. And it only worked, the Pythagorean theorem, with right-angled triangles. So with right-angled triangles, we know, or we can use more information than for any old triangle. So trigonometry is when we study the relationship between the side lengths of a triangle and the angles of a triangle. And it's based on right-angled triangles. So we're finally going to be able to develop or look at some problems where we know angles and sides, and we can use them together to do some work with triangles. So there's some vocabulary we need to start with. So there's my right-angled triangle. I can see there's a right angle right here. And I can see that there's an angle that's marked. And an angle that's marked is important because it sort of tells you this angle is important right now. And So that actually tells us what the first new piece of vocabulary is, which is that angle that's important to us gets a special name. It's called theta. And, sometimes we can just call it x, but to learn, we're going to call it theta. And it kind of looks like, I always think of it as the planet Saturn. I draw it like that usually because I can't, it's hard to get that line exactly where it fits. So theta is officially the reference angle, but really it's the angle that we know, or the angle we want to know, or just the important angle of the question. That's going to be called theta. Now, we also need to know the hypotenuse. So you should know where the hypotenuse on a right angled triangle is, because you've worked with Pythagorean theorem before. But I just want to sort of show you a new way of thinking about it, because I don't like when students say the longest side. Just, I don't know. So if you know you have a right angle, which we do, then use the box of the right angle to help you find the hypotenuse. The hypotenuse is the side opposite the right angle. That's the hypotenuse. That hasn't changed in what we know it was going to be. It's the other two sides, so this side and this side, that have to have new names. So one of them is going to be called the adjacent side. And what's really important is, how do I figure out which side is adjacent? Well, adjacent means next to. I'm standing adjacent to, or I'm standing next to someone. So basically, if you look where theta is always going to be in this corner between the hypotenuse and the adjacent. So hypotenuse will always sort of trace this little corner path to find the adjacent. So adjacent means next to theta. And of course, the hypotenuse is next to theta, but it's already got a name. So it's the other one that's next to theta. That's the adjacent. And the other side is called the opposite side, because it's on the opposite side of the triangle from theta. So you'll notice, other than the hypotenuse, we're really focused on where theta is. That's why we needed to know theta. So here's theta, and on the opposite side of the triangle, there's the OPP, the opposite side. So we have to be able to label the sides of our triangle and our reference angle with these names. So here's a practice question for you. Can you label theta and the sides of the triangle? So the angle that I know is this marked angle. So there's theta. If I find the right angle, I can use it to point to the hypotenuse. And then what I always do is, once I know theta and the hypotenuse, I start at the hypotenuse and I trace around theta. In class, I call it hugging theta. And this side is the hypotenuse, so the other side must be the adjacent. And then, of course, there's a missing side. The other side is the O side, which is opposite. So I think of it as the other side, but it is the one that's opposite on the triangle. Here's another one for you to practice on your own. So if this is theta, which it is because it's marked, then I can find the hypotenuse over here using the right angle, trace the hypotenuse, circle around theta, that's the adjacent side, and then the other side is the one opposite theta, so that's opposite. So you also need to know what the trig ratios are. So trig is all about these ratios. There's the sine ratio, the cosine ratio, and the tangent ratio. And of course, these are those buttons we talked about earlier, sine, cos, and tan, on your calculator. So the sine ratio is the ratio of side lengths, and sine is opposite over hypotenuse. So sine is the ratio opposite over hypotenuse. And then we have the cosine ratio, which is adjacent over hypotenuse, so adjacent over hypotenuse. And of course, tan is the ratio opposite over adjacent. So you need to know those trig ratios. Those form the basis of trigonometry. And there is this, I don't know, is it a mnemonic? this word that seems meaningless, SOHCAHTOA. You're going to hear me say that a lot in class. But SOHCAHTOA, a fairly easy thing to remember if you say it enough, tells us that sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tan is opposite over adjacent. So the word, meaningless word, SOHCAHTOA, is telling us these ratios. And it's a simple way to remember them because you just remember this word, SOHCAHTOA. So let's practice. So here's information I have in the triangle. I have theta labeled, but not the sides. So we're going to have to start by labeling the sides, and then we're going to have to figure out which of sine, cosine, and tangent could be used based on the sides we know. So hopefully you tried to think about that on your own, but if this is theta, then here's the right angle. So this is the hypotenuse. The hypotenuse, theta, and adjacent are always in this little hug. So this is the adjacent side. So this side must be the opposite. So I've labeled my sides. And the sides that I know about are the hypotenuse and the adjacent. I don't know the opposite. So we need some ratio that involves adjacent and hypotenuse. Oh, I just changed my marker. That's fine. So using SOHCAHTOA, sine is opposite over hypotenuse. Well, I don't know the opposite, so it's not that one. Cosine is adjacent over hypotenuse. The two sides I have are adjacent and hypotenuse. So this relationship I would write as cosine theta is adjacent over hypotenuse. So setting up the ratios is really important. So I want you to practice this one. So we can see that theta is right here. And this is the hypotenuse. The hypotenuse always hugs the adjacent. So there's the adjacent side, which means this side, this other side must be the opposite. So the two sides that I was given were the, oops, sorry, wrong pen. Oh no, bear with me. There we go. So the sides that I know about are the opposite side and the adjacent side. So looking at SOHCAHTOA, which of SOHCAHTOA makes the most sense to use? What could we use? Well, sine is opposite and hypotenuse. I don't have hypotenuse, so I can't use sine. Cosine is adjacent and hypotenuse. Again, I don't have hypotenuse. Tan is opposite over adjacent. That's what I want. So I could say that tan theta is opposite, which is 6.8, over adjacent, which is 11.2. So label the triangles, label the sides, identify the trig ratio. So the next thing we need to know, we haven't even done math yet, we're just setting up all the little background pieces we need, is that your calculator is going to be really important. I mean, obviously it has those trig buttons. So we know, for example, that sine is the ratio opposite over hypotenuse. Your calculator knows what that ratio is. So if you type sine 56 equals, it will give you 0.8290. Now, I know it actually gives you 0.290375772, but we have the rule in trigonometry where you keep the first 4 digits of the decimal, and the first digit I'm getting rid of is a 3, so I don't need to round up. So 8290. That's what sine 56 is. Now, hopefully you're thinking, well, wait a minute. If sine is supposed to be opposite over hypotenuse, why didn't I get a fraction? Or why didn't I get 2 different numbers to put into a fraction? Well, that's because you have to be part of your calculator's team. So when you type sine 56, your calculator is going to give you the number that goes in the top of that ratio fraction. You just have to remember to put it over 1. And when you put it over 1, you've done your memory work. So the calculator knows the hard part. You got the easy job, which is over 1. That's how your calculator is going to help you. So now we're actually going to do a trig question. So we have all these things we need to know. Let's put them together. So here are the steps. First, we need to identify theta. Oops. One second. Okay, fixed the issue. So these are the steps in order to use trigonometry, basically. So what we need to do, so our goal is to solve for x. So x is right here. It's one of the sides of the triangle. So the steps are that we have to identify theta. So theta is the angle, I know that's 38 degrees. I have no idea what this angle is, so why would I make that theta? Again, theta represents the angle we know, the angle we want to know, the important angle. So I'm going to call this theta. Theta is 38 degrees. And then I can say, well, there's the right angle, so this is the hypotenuse. The hypotenuse always hugs theta with the adjacent. And then the other side of the triangle is the opposite. So I have identified theta, labeled the sides. Now I have to think about what SOHCAHTOA relationship I want. So SOHCAHTOA. So here's what I have in the diagram. I have the opposite side I know about. It's 14. The hypotenuse is the one I want to know. It's x. And you'll see I don't know the adjacent, and I don't want to know the adjacent. So adjacent's irrelevant. I need opposite hypotenuse. So if we look at SOHCAHTOA, sine is opposite over hypotenuse. Well, that's exactly what I want, opposite hypotenuse. So I'm going to be using the ratio sine theta equals opposite over hypotenuse. So what information do I know from the problem? Sine 38 is 14 over x. So now I need my calculator, because I need my calculator to figure out what sine 38 is. And remember, I will do the hard work of remembering divide by 1. It's not actually hard work. So when I type that into my calculator, I get 0.6157, and I put over 1. So that's the ratio. And then in this particular triangle, I have the side lengths 14 and x. So now I just have to solve for x. So the way that we talk about this in class is we do something called cross multiply. So there's the equal sign. Hold on. So what I do is I look for the equal sign and I multiply the numbers that are across each other. So in that diagonal. So I'm going to do 0.6157 times x, and I'm going to do equals 14 times 1. So I don't have fractions anymore. Now, solving for x, I need to now get rid of this multiply x by 0.6157. And the way to get rid of a multiply is to make it a divide. So I'm now going to divide by 0.6157 on both sides. So on this side, I'll be left with just x. And then in my calculator, if I do 14 divided by 0.6157, I get 22.7. So in our final answer for side lengths, we round to 1 decimal place. So that is a trig question. Let's do another example because I know there's a lot going on. So I need to solve for x, and x, as you can see, is this unknown side length over here. Oops, didn't mean to cover it. Which means I'm going to start the process of doing trig. I'm going to identify theta. So theta, this is the angle that I know, and I have no idea what's going on here. I don't want to know. I don't care. This is theta. So now I can say, okay, here's the hypotenuse. Trace hypotenuse around the corner. This is the adjacent. And then the other side is opposite. So now I'm going to think about SOHCAHTOA and which of sine, cosine, and tangent should I use. So the side I want to know, hold on. The side I want to know is the opposite side. The side I do know is the adjacent. And hypotenuse is irrelevant. I don't want to know it. I don't know what it is. So I need to figure out which trig ratio I can use that involves both the opposite side and the adjacent side. So sine doesn't work. Opposite over hypotenuse, not sine. Cosine doesn't work. That's adjacent over hypotenuse. Tan is opposite over adjacent. And opposite and adjacent are the sides I have. So this is going to be a tan question. So tan theta, 72, is opposite over adjacent. So we set up the ratio using what SOHCAHTOA tells us. SOHCAHTOA tells us that tan theta is opposite over adjacent. Now I'm going to use my calculator and to figure out what tan 72 is. So when I type that in, I get 3.0777. I'm going to put it over 1 because that's my job. Calculator's got the hard job there. And now, just like in the last question, I've got a fraction equal to a fraction. So we solve by cross multiplying. I'm going to multiply this one times this one. So 3.077 times 3.2 gives me 9.8. And then, well, this was just 1 times x. So I'm done. X equals 9.8. So you'll notice we don't always have to do the divide by step you saw last time. It just depends on where x is. So what I want you to do is I want you to pause the video and try to do this one as far as you can before I show you the solution. Okay, so we are solving for x, where x is a side length. So first I'm going to identify theta. That's the angle I know. Then I can say there's the right angle. So this is the hypotenuse over here. The hypotenuse hugs the adjacent. And then there's the opposite side over here. So which trig ratio is important here? So the sides that I care about, well, obviously I care about the hypotenuse because that's the unknown. And the adjacent's important because I know what it is. And you can see the opposite's like not worthy of my time because I don't know it. I don't want to know it. So now I think about SOHCAHTOA. Oops. So using SOHCAHTOA, which of these ratios is important or useful? Sine is opposite over hypotenuse. Well, I erased it because it was irrelevant, so hypotenuse can't be used. Cosine is adjacent over hypotenuse. Well, those are the two sides that are important. I have or I want to know. So this is a cosine question. So cosine theta is adjacent over hypotenuse. So I set that up using SOHCAHTOA to remind me how. Then I take up my calculator and I type in cos 46. I get this 4-digit decimal. I put it over 1 equals 60 over x. And now we cross multiply. So I'm going to do this 0.6947 times x. And then the other one I will do 1 times 60. That's an easy one. So, well, I mean, neither of them really that hard, but so 0.6947 times x equals 60 times 1. So again, I've got that situation where I want x isolated, so I need to get rid of 0.6947. And right now it's multiplied, so I'm going to divide both sides by 0.6947. So over here, I'm left with x equals, and when I do in my calculator 60 divided by 0.6947, I get 86.4, rounded to 1 decimal place. So the length of this side is 86.4, which makes sense because that's 60. So yeah, good. Here's another one. I want you to pause and try it on your own. So we will identify theta right here. That's theta. This shows me the hypotenuse is over here. And if you trace around theta, you'll always find the adjacent. And then I've got the opposite side. So now I need to think about which trig ratio. So katoa. So I can see that I have the opposite. Ooh, that's not a good color. Oh well. We know that we have the opposite side, which is 10. We have the adjacent side. Well, we don't know it, but we would like to. That's x. And I don't care at all about the hypotenuse. So the hypotenuse is the one we don't care about. So which ratio uses opposite and adjacent? So it's not this one. That uses hypotenuse. It's not that one. This is a tan question. So tan 60 equals opposite over adjacent. Then I asked my calculator to calculate tan 60, 1.7321 over 1 equals 10 over x, cross multiply. 1.7321x equals 10. And then divide both sides by this number. So x equals 10 divided by 1.7321 is 5.8. And yeah, I can accept 5.8. That's 10. So 5.8 is a reasonable answer. Okay, so that's using trigonometry to find the side length. In each of those questions, x was the side length of a triangle. But now I need to show you sort of the inverse operation. So again, I need you to look at your calculator. And what you should notice is that where your sine, cosine, tangent buttons are, behind them, sort of like written on the calculator, it's called the second function of that button, are things that look like this. Sine -1. So that's just telling you that this is what undo sine. It's remove sine, or inverse sine is what it's officially called. So what they're used for is using trig to find an unknown angle if you know the two sides. And we'll look at an example, obviously, in the next slide. But for now, just use your calculator, please, and make sure that you can calculate the values of inverse sine 0.3090. So means finding the shift or second function. Usually, as the diagram shows, it's in the upper left. Again, get to know your calculator. So when I type it in, I get, my calculator shows 17.9989. Well, for angles, we like no decimal places. I'm going to round that to the nearest full number, which is 18. And then in order to do this one, the tan question, it's easy to just use that bracket. Like just type it in with a bracket, and then you can do 13 divided by 18 or 13 fraction 18, whatever you're comfortable with, whatever your calculator has, as long as you use that bracket. And what you should get is 35.8, which we're going to round to 36. So that's how you'll use the button. So now let's look at it in a math problem. So we're using trig now to find an angle. So you can see this angle, what? Question mark, that's what I want to find. It starts the exact same way. That's what we like about trig, is that it sort of always has the same beginning process. Identify theta. Well, obviously, that's the important angle. I want to know it. Then I'm going to label the sides. So this is the right angle. It points to the hypotenuse. If I go from hypotenuse, turn the corner at theta, I've got the adjacent. And then I've got the opposite side of the triangle, or the other side. So now I have to figure out, using SOHCAHTOA, which trig ratio is going to be helpful in this question. So which information do I have, or what information do I have? I know the hypotenuse, and I know the opposite, and I do not know the adjacent. That's fine. I know two of the sides. And because I know two of the sides, I'm going to use those two sides to set up my trig. So the two sides that I know are opposite and hypotenuse. So that's exactly what sine wants. Sine says opposite over hypotenuse. So this is a sine question. So I'm going to set up sine. Sine theta equals opposite over hypotenuse. Now this time I can't just go to my calculator and type in sine theta because obviously theta is not a number. But what I want to do, therefore, to solve for theta is I want to remove sine from theta. I want to undo sine or do inverse sine. So that's exactly what I'm going to do. I'm going to do inverse sine. So I'm going to do this just the one time, and then you'll just see the shortcut. Basically, it's sort of like how I divided by both sides in other questions. I'm going to do inverse sine on both sides, but that just leaves me on the left with theta, and on the right, I have inverse sine 19 over 27. So really, what I'm doing is I'm taking sine and I'm moving it to the other side, as we like to say. And when it moves to the other side, it becomes that. So I'm not multiplying it, I'm not dividing it, I'm not adding it. I'm inversing it, so it looks like this. And now this is exactly what we just practiced, is using the right buttons on your calculator. So I'm just going to type that second function sine to get inverse sine. And then I'm going to use a bracket, 19 divided by 27, close the bracket. And then my calculator says 44.724 blah, blah, blah. So I want to get rid of all the decimals, and the first number is a 7, so I need to round up. So that is 45 degrees. Kind of almost easier than the other one. Let's try another example. So I need to identify theta. Well, nothing's marked, but if you look up here, it tells me to solve for the measure of angle B. In other words, find angle B. So angle B is this one, so that one must be theta. So sometimes we have to read the actual question. Crazy, right? So if that's theta, let's label our sides. So here's the hypotenuse. This is the hypotenuse there. If I hug theta, I find the adjacent, and then the other side is the opposite. So now that I've labeled my sides, I think about SOHCAHTOA and which of those is going to be useful in this situation. So I have the opposite side, I have the adjacent side, and not the hypotenuse. So I need the ratio that uses opposite and hypotenuse. Nope, opposite and adjacent. So it's not sine because I don't have hypotenuse. It's not cosine. This is a tan question. So tan theta, or I'm going to write B because the question wants to call it B, so why not? Tan B, which is theta, is opposite over adjacent. And now I need to get rid of tan, and the way to get rid of tan is to do inverse tan, move it to the other side, inverse tan. And then remembering to use my bracket. So now I just have to type that in. Inverse tan, bracket, 14 divided by 10 is 54.4. So I don't round it up. I leave it at 54. So angle B is 54 degrees. Okay, here's another one. In this question, we're finding angle A. So angle A is here. I would identify that as theta. That's important. So here's the hypotenuse. Trace around theta to get the adjacent. And then the other side of the triangle is the opposite. So SOHCAHTOA. Which of those do I need to use right now? Okay, good question. Which sides do I have? Which sides do I want to have? Well, I don't want to have any side. I want the angle. So the adjacent I know about, and the opposite I know about. So I need to use the trig ratio that uses adjacent and opposite, which is tan. So I'm going to set up a tan equation. So the tan of theta, which I'll call A, because the question also said A. Tan theta is opposite over oops, why did I write that? Opposite over adjacent, and feel free to make that 2, but I'm just going to proceed the way I always do. So I need to solve for a, so I need to move tan over where it becomes that. And then just type this into your calculator. Inverse tan, bracket 12 divided by 6 is 63 degrees. I hope that's what you got. Here's another one to practice. So this time I'm asked to find angle T. So angle T obviously therefore becomes important, and we will call that theta. Hold on. So angle T is theta. There we go. So that's theta. Boop, 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 boop. This is the hypotenuse. And then if I hug theta, I find the adjacent. And over here is the opposite. So which of so, ka, toa do I need? So, ka, toa. Sometimes I like to X pronounce the H. So the sides that I have that are useful to me in this question are opposite and hypotenuse. So which one do I need? I need sine. So I'm going to say that sine T, you can also use theta, is opposite over hypotenuse. So now I need to move or get rid of sine. So T is inverse sine 24 over 25. So I'm going to type that into my calculator. Inverse sine, bracket 24 divided by 25 is 73.7. So I would say 74 degrees. Hope you got that. So here's the key learning in this video. We learned how to label theta and then how to label the sides based on theta. Opposite, adjacent, hypotenuse. We learned that the trig ratios can be remembered using this weird word so, ka, toa, because sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. We did some practice questions where we used trig to find a missing side length. We did some practice where we learned to find a missing angle. And we also talked about the rules for rounding decimals, which is 4 decimal places when you use your calculator to get, sine 30, whatever. We learned I like 1 decimal place for a side length, and angles, no decimal places. So there's more to learn. In another video, I can talk about problem solving with trigonometry. Thanks for watching.